The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. We have come to the next chapter, that is the third chapter, classification of elements and periodicity in properties. See, before getting into today's class, I just want to remind my children about being confident and believing in yourself when you are attending your online exam. Exam is just a medium to assess you. It is not with one exam we can assess a child. It is just a support that a teacher is giving to you to make you comfortable or to make you understand where are the areas that you need to concentrate more. So children, I want you to cooperate with the teachers, because unless and until you cooperate with us, it is not easy for us to make this program a successful one, right? Don't have fear, because it is your teachers who are going to ask you questions. So I want you all to be comfortable, learn the best that you can do, and try to be with the syllabus. Do not keep anything in pending, right? Because it is us who is going to face the difficulty in the future. So wish you good luck, children, and till now I heard from the teachers that you have done well. Keep on continuing this spirit, and I know my children are very, very, very energetic and you can do it. Okay, wish you good luck for every one of you. All the best, children. So let us start today's class. Today's topic is classification of elements and periodicity in properties. As we all know, we have been learning with the periodic table right from our 8th, 9th standard. You have been seeing a colorful periodic table in your chemistry textbook, right? So we are going to just see how did it come, or what were the reasons that were causing to make a periodic table. See, why do we need to classify elements? Now when you go to a vegetable shop, you don't see all the vegetables put together, or when you go to a supermarket, you don't see all the grocery items put together in one particular shelf. It is being classified according to their properties, according to their use in our daily life, right? So similarly, when we come home, you see when your mother brings a vegetable bag, once she comes, she will sort out the things which have to be kept inside the refrigerator, things which have to be kept outside, or things which have to be washed immediately, which have to be transferred to the bottle, because these hold certain properties that they have. Some may react immediately. If you see tomato, when it's kept outside for more than 2 days, it will go waste. You cannot use it. So it has to be refrigerated. Similarly, there are elements which are showing certain trends, certain properties towards the other elements or towards the things that they react with. So these properties make them to be assigned a special place in a table, and that is called as a periodic table. So scientists were working very hard to make them group into different places so that they hold the same property. They all belong to the same group which are showing the similar properties. So that's how this classification of elements gave into rise. So now you will be seeing a video to see the classification of elements and why it is required. What is the need of the classification and the periodic table? We group similar things together because this makes our life easier, like vegetables, fruits, groceries in supermarket. Similarly, in library, books can be classified on the basis of class, subject, etc. We keep the same type of clothes together, like t-shirts together, shirts together, trousers together, for our convenient use. We can group things on the basis of similarity and dissimilarity in their properties. Classification is important for handling huge collection of objects, utilities and information. We classify things and information on certain bases which may vary according to the need. Now let's talk about chemistry, where we deal with many elements and so classification is necessary. Till 18th century, only few elements were known. Therefore, it was easy to study and remember the properties of these elements. At the end of 19th century, several new elements were also discovered and more information about their properties were gathered by the scientists. As the number of new elements discovered increased, it was very difficult to study each and every element individually. Therefore, scientists realized that there is a need of system which keeps track of them all. Several scientists like Daubers, Newlands, Lothar-Meyer made several efforts to classify the elements. The first meaningful classification was given by Russian scientist Dmitry Mendeleev in 1869. Mendeleev's classification is based on atomic masses and their physical and chemical properties. Mendeleev studied the physical and chemical properties of the elements and classified them on the basis of a law known as periodic law. According to this law, the physical and chemical properties of the elements are the periodic functions. Mendeleev arranged the known elements in the order of increasing atomic masses in the form of a table, and the table is known as Mendeleev periodic table. Mendeleev periodic table has horizontal rows called periods, which are numbered from 1 to 6. It has 8 vertical columns called groups, which are numbered from 1 to 8. There are 2 groups A and B. So whenever Mendeleev reads an element whose property is different from its previous element, he placed the element in a different group. Many scientists have worked on the classification of elements, but why Mendeleev's work is appreciated, let's understand. Mendeleev was able to classify all the known elements and gave a new direction for the research to the scientist. Henry Moseley in 1930 searched more and more fundamental way for classifying the elements. He arranged the elements in the periodic table by their number of protons rather than their atomic weights. This discovery changed the whole perspective of the elements in the periodic table, and the research was done for several years and was led to the modern periodic table, which is used till date. Let's quickly summarize. I hope you saw the video regarding classification of elements, or why we need to classify the elements. Now we'll get back into genesis of periodic classification. Genesis of periodic classification means what are the things that were involved in creating a classification for the elements in the periodic table. So we are going to start with law of triads. See, this we have learnt in the previous class, children, if you remember how in your lower classes, 9th standard and all, you would have studied about this. Law of triads was developed by scientist Daubers, and what he said, triads means 3. He said when you consider 3 elements, in that the middle element of each of the triads, when you take a 3 element series, the middle element of each of the triads had an atomic weight about halfway between the atomic weights of other two, which means, I'll put in simple words, let's take lithium, sodium, potassium. They all belong to one row. So when you take lithium, sodium and potassium, lithium plus potassium is around 46. When you divide by 2, you get 23, which is the atomic weight of the middle element. So it is halfway through lithium and halfway through potassium. That is how he said law of triads, and this was continuing even with chlorine, bromine and iodine. That is, the middle element of each of the triad had an atomic weight which is halfway through the atomic weights of the other two elements. But what happened? This was not being able to get satisfied when you go to elements with higher atomic weights. So then this was dropped, and there was another scientist who had been arranging the elements according to their atomic weights in the increasing order. But even when that became failure, the next law was law of octaves. Now before seeing law of octaves, you will see a small animated video about law of triads. Daubers Law of Triads. In 1829, German scientist Daubers was behind the law of triads. He classified that elements having similar physical and chemical properties falls in the group of 3. He classified these relative group of elements as triads. Daubers law of triads says when 3 elements are arranged in the order of increasing atomic mass, the mass of the middle element will be approximately the average of the mass of the 2 elements. To understand this law, let us consider the triad of lithium, sodium and potassium. With lithium, sodium and potassium, if their atomic masses are calculated, for lithium it is atomic mass 7, and for sodium it is 23, and for potassium it is 39. And if an average of the lower and the higher atomic masses are taken with 7 and 39, 23 will be the answer, which is the atomic mass of sodium. So 7 plus 39 by 2 is equal to 23, which is the atomic mass of sodium. That is the law of triads. Now let us consider one more example with chlorine, bromine and iodine. With this example, if the atomic mass are calculated, for chlorine it is 35.5, for bromine it is 80, and for iodine it is 127. If the average of the atomic mass of chlorine and iodine are taken and it is divided by 2, you get 80 as an answer, which is the atomic mass of bromine. 35.5 plus 127 by 2, that is 81.25, which is closer to around 80 atomic mass of bromine. Now law of triads, though it is not for all the elements, it can be applied to very few elements in the periodic table. So I hope you understood the Daubers law of triads, and this is the summary. I think now you are able to understand law of triads, right? Because I believe, children, seeing is believing, right? When we say words, pictures, when we show, pictures speak louder than words. So I think that is giving you full information about law of triads. The next scientist was John Alexander Newland, who gave the next law, which is called as law of octaves. Oct means 8. So what was his law? When he was considering the elements in the periodic table, and when he was analyzing the elements, the way they have been placed, he said every 8th element had properties similar to the first element. Now what does it mean? Now let's take the first row. When I say lithium, after lithium we have beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So 1, 2, 3, 4, 5, 6, 7 and the 8th element is again sodium, which is showing the properties similar to that of lithium. That was law of octaves. Every 8th element will show the property similar to that of the first element. So after sodium, when I take magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, and then what comes? Potassium. So lithium, sodium, potassium will be holding similar properties. But what happened when it was being analyzed with all the rows, only till calcium, this law of octaves was successful. After calcium, when it was started with scandium, that is a transition element, D block element, this law became a failure. Again, it did not go with the law of octaves. It did not show the similar properties with every row or every group. So then law of octaves was also stopped. Then came the scientist Mendeleev, who gave a wonderful concept of periodic table, assigning all the elements according to their atomic weight. So now we will be seeing Mendeleev periodic table law, but before that you will be seeing a video with law of octaves. Newland's law of octaves. Newland's law of octaves was proposed in 1866. According to this law, on the periodic table, any element will be similar to the element found at the 8th place beyond it. In other words, when elements are placed in increasing order of atomic mass, the properties of every 8th element will be similar. Because of the similarity in the 8th place, as in the case of musical octaves, he named this as law of octaves. This table included 56 elements, all of which were arranged in increasing order of atomic mass. According to this law, lithium will possess similar property with the element 7 places beyond lithium, that is sodium. Similarly, beryllium will exhibit properties similar to the 7th element beyond that, which is magnesium. The same will hold throughout the elements such as boron and aluminium, carbon and silicon, nitrogen and phosphorus, oxygen and sulfur, which displays similar properties. Unfortunately, Newland's law has some drawbacks. Sometimes two elements may fall into the same group, but their properties will be different. For example, cobalt and nickel, which are put in the same slot of fluorine and chlorine, which have different properties. But iron, which is similar to cobalt and nickel, was grouped with oxygen and sulfur, which are non-metals. Because of these problems, law of octaves was found acceptable only for lighter elements, that is up to calcium. Summary. Newland's law of octaves states that when these elements are placed in an increasing order of atomic mass, the properties of every 8th element will be similar. The law of octaves was found acceptable only for lighter elements and only up to calcium. So children, after this law of triads and octaves had come, it was Mendeleev in the year 1869 with Mayer, the scientist. He designed a periodic law, and what he did was he was arranging the elements in the increasing order of their atomic weight, that is atomic mass, where there was a similarity in the physical and chemical properties of the elements like melting point, boiling point. But what happened is that, so when he designed the law, he was stating that the properties of the elements are a periodic function of their atomic weight. What does it mean? When I say this element has got certain property and these 3 elements possess the same property, it is just depending on their atomic weight. That is called as periodic function of their atomic weight, wholly responsible for the atomic weight of the element. That is why they are grouped together. But what happened when he started arranging the elements according to atomic weight, there were few gaps, or there were some of the elements which did not fit into that. That is, he was making horizontal rows and vertical columns. When I say vertical columns like this and horizontal rows like this. But there were some elements which do not fit into the group. So like gallium, germanium, there were gaps in periodic table that these elements were not having the properties similar to the properties in the same group. Those exceptions made Mendeleev think a lot about what could be the reason, whether the atomic weight may be wrong or the elements are different from the elements which are in the same group. So then he just adjusted. He studied the characteristic properties using X-ray. That is, he studied the characteristics of the elements using the X-ray spectroscopy. Then he drew a graph between the frequency, the square root of frequency and the atomic number, where when he got the straight line, that shows that the graph is valid. So he realized that instead of atomic weight, it should be atomic number. So what this law became, the Mendeleev periodic law was restated as modern periodic law, and then it is called as the physical and chemical properties of the elements are periodic function of their atomic number. I will repeat again, the physical and the chemical properties of the element are the periodic functions of their atomic number, which means if I am going to say any physical or chemical property of any particular element in that particular group, it is just because of their atomic number, which is wholly dependent on their atomic number. That is, this law was called as modern periodic law. From then he started studying about the nucleus and how the electrons are arranged, and then he came to know how the last electron was similar to the same group, like the first group having one electron in its outermost shell. The second group was having 2 electrons, and the first 2 groups used to lose the electrons, or when I say 17th group has got 7 electrons in the outermost shell. So these were the similarities that he studied with the modern periodic law. Now you will be seeing a video with respect to the arrangement of elements in periodic table, law of triads, law of octaves, Mendeleev periodic law, modern periodic law. With them we will get back into the groups and periods. Periodic table. In the world of chemistry, there are many elements which were initially found out, and later there were more and more number of elements which cannot be identified that easily. We need a special technique to arrange these elements and to find out the desired element that we want. In such a situation, these elements were studied by the scientist, and different laws were being stated by each scientist depending on the properties and position in the periodic table. The first and foremost was to identify the properties of these elements. So these elements had a special characteristics feature with respect to atomic mass or any other physical and chemical properties. So in 1800, it was scientist Daubers who found out the law of triads. According to this scientist, lithium, sodium and potassium was taken, and the atomic mass of the element in the middle of the table was approximately the arithmetic mean of the atomic masses of the first and third elements of the table. And this was with very few elements in the periodic table. Later, it was Newland's law of octaves, where he studied when elements were arranged in the increasing order of their atomic weights, the properties of the first element were similar to that of the eighth element. So, the first and eighth element were similar. It was just resembling the musical note with the octaves of the first one resembling the eighth one. So he named this law as law of octaves. After all these scientists have been studying about the element and its properties, it was Mendeleev who designed an temporary periodic table assigning the elements a position with respect to their properties. It can be physical properties like melting point and boiling point, and it also includes some of the chemical properties, the reactions that it underwent. According to Mendeleev's periodic table, he stated the properties of the elements are periodic functions of their atomic weights. According to this, the elements were given a positions with respect to one by one below each other that were similar in the properties. Later, he designed that the atomic weights were not that perfect and there was some inaccuracy. So he designed a law which is modern periodic law. According to this law, the physical and chemical properties of the elements are periodic functions of their atomic numbers. Then he came to know that atomic numbers play a very important role in the periodic table, and every element were arranged according to their increasing order of their atomic number. So that is how the elements were given the positions in the periodic table, and there were 7 horizontal rows and 18 vertical columns which are called as groups. The 7 horizontal rows are called as periods. So altogether we can say the elements in the periodic table are arranged according to their increasing order of their atomic number. And it says it consists of 7 periods and 18 groups. Every single group placed in the periodic table has the outermost electronic configuration similar, that is the number of valence electrons being similar in each group, right from group 1 to group 18 in the periodic table. With this, he also studied that there were 2 elements in the first period, and then consistently it was 2nd, 3rd, 4th, 5th and 6th, 7th period. Then comes the F block elements. These scientists were making sure that they named these elements with their name who were behind the research and the invention of the element. But later, one element being found out by 2 or 3 scientists, there were controversies which led to the difficulty in giving the name to the elements. So in such a case, IUPAC, International Union Pure Applied Chemistry, gave a structure for the nomenclature of elements right from root name and the number right from 0 to 9. And this was the basics in naming the elements above 100. Write the corresponding root names with respect to digits of the atomic number of the element. Put together the root names in the order of the digits, forming the atomic number of the element, suffixium to the new name, that is add IUM to the new name. So this was the rule to write the names of the elements which are above 100. You can see here an example right from 101 to 110.
Okay, now we will get back into the long form of periodic table, where you can see we have 7 horizontal rows which are called as periods and 18 vertical columns which are called as groups. So the similar property element will be placed in similar groups, that is vertical columns, not in rows, in columns. So similar electronic configuration, we will be seeing the first group having 1 electron outermost shell, second group with 2 electrons, third group that is with 3 electrons, that is from 1 to 18 you have, where we have already studied about SPDF, which we will be seeing in the next class again to understand much better about the classification of blocks in the periodic table. Every period number represents the principal quantum number, that is the shell with which the energy of the electron is placed. If you see page number 77, you have 2 important tables which represents the nomenclature IUPAC name
and the elements with atomic number greater than 100. These come definitely for 1 mark question. So, do not leave it blank, definitely consider is very important and have a look on it, learn it by heart. Once you learn the IUPAC name, you will be able to write with any element above 100. So, with this the periodic table introduction is over. The next class we will get into electronic configuration and also to learn more about S, P, D and F. So, thank you children. Go through the class then and there. I know you have exams, but still place yourself a time to see the classes which are also equally important for you. Right? If you have any doubt, do call me. Stay home, stay safe. Thank you children. Take care.